TGB channel. Myself, Kumar. In this video, I will discuss about the nodal analysis. It is very important technique which can be helpful and useful to find out the unknown response in the given circuit. First of all, how to find out the nodal analysis? Suppose in the given circuit, we have number of nodes are n. We have n number of nodes in the given circuit. Then we have to find out the number of nodal equations. The equations which are developed according to the nodal analysis, then they are called the nodal equations. Then the nodal equations, the formula is n minus 1. When in the given circuit, including reference node, then the number of nodes be n. Then you can write down the number of nodal equations is n minus 1. And also, you can develop the nodal equations based on the Kirchhoff's current law, that is KCL. By applying KCL at every node, then you can draw each nodal equations. Okay. So, for example, in the given circuit, we have two number of nodes other than reference node. Then you have write down the two nodal equations. And also, if there is a voltage source between the two nodes, then that is called the super node analysis. You can write down the nodal equation based on the super node when the circuit consists of a voltage source between two nodes. That analysis is called the super node analysis. Then, for example, how to write the nodal equations? Then you consider the circuit here. For example, take one circuit, then having one voltage source and one current source. Then find the nodal equations or write down the node voltages. After writing nodal equations, then you have to find out the node voltages at every node. Before going to write down the equations, you must analyze what are the number of nodes in the given circuit. For example, here, this is called the reference node. In the given circuit, always you can take the node where the current divides. Okay, here, suppose current is passing like that here 5 amperes, then at this node point, current will be divided. That's why it is taken as one node. That voltage we can take as V1. Similarly, at this node also, current will be divided. That's why there is taken as second node. I am taking as voltage V2. If there is no current divided, then it is not take that node point. You must take the node point where current will be divided. Then at each node point, at each node voltages, then you can develop the node equations. Okay. For example, here and also very important point is you can consider the current direction away from the node passing through each element. Okay. For example, here apply KCL. That means you have to write down the equations, apply KCL at node V1 at first node. At each node, you can apply KCL here. Before going to apply KCL, then you can draw the simple circuit at each node. That is, in the given circuit, you can write down this is voltage V1 and this node voltage V2 and this is given as 3 ohms. You write down equal circuit at corresponding node. Here we are writing equations at V1. Then what are the elements are connected at V1? You must show at V1 node here. these are the elements are connected at V1 node. Then all elements are connected to reference, that is the ground node. Okay, this value is nothing but is 10. Okay, at this V1 node, the 5 amperes also should be entering into the node, and 10 ohms connected V1 and 3 ohms also connected V1. At the end of the 3 ohms, we have the another voltage, that is V2. Okay, then here you must analyze the current directions. Always you can consider the current directions are away from the node passing through the element, and what 5 ampere source will be entering, and current passing through 10, current passing through 3 ohms are leaving from the corresponding node. Then apply KCL. What is KCL? Number of currents entering, sum of the currents entering into the node is equal to the sum of the currents leaving from that node. Okay, then what are leaving entering current? That 5 amperes will be entering current, equal to what is the current passing through 10, that is v according to Ohm's law, v equal to IR, I equal to v by R. Then the voltage across 10 is V1, then the current passing through 10 is V1 by 10 plus sum of leaving currents. Then what is the current passing through 3? That is, but 3 ohms having two voltages, one end V1, one end V2. Here we are writing equations for V1 node. That's why the voltage value is nothing but V1 minus V2 by 3. Then simplify the equation here. Common V1, that is 1 by 10, 1 by 3 into V1 minus 1 by 3 V2 equal to 5. Then simplify the equation, you will get here 0.43 V1 minus 0.33 V2 equal to 5. Then this is considered equation 1. In the similar manner, you can write down, that is apply KCL at node V2. That is, must draw the circuit at node V2. Then at node V2, this is V2 and this is V1 connected 3 ohms. Okay. In the given circuit, what are the elements are connected at node V2? That is 5 ohms are connected and 1 ohm joining with 10 voltage source also connected. Then you can connect the remaining elements at node V2. That is 5 volts connected, then ground, and another one source connected. That source should be joining with a 10 voltage source. This is 1 ohm. Then what is the assumption here? You can take the current directions are away from the corresponding node. Here we are writing equations for V2 node, then all currents are away from the node. Okay, this is a very important point. We must take the current directions are away from the corresponding node. Then apply KCL at V2. That is, here there is no entry current. All currents are leaving. That's why the current passing through 3 ohms is, then here V2 minus V1 by 3. Why we are taking as V2 positive? Here we can take the applied equations for V2 node. That's why taken as V2 is larger than V1. Then plus Again, current passing through 5 ohms is nothing but V2 by 5. Again, current passing through 1 ohm nothing but here V2 minus 10. Here 10 voltage nothing but the positive terminal is connected to the V2 side. Suppose 10 volts will be reversed. That is minus is first terminal. Then taken as V2 plus 10. Okay. Remember that point here. Then V2 minus 10 by V1 equal to 0. Then common terminal here minus 1 by 3 V1 plus 1 by 3 plus 1 by 5 plus 1 into V2 equal to minus 10 going to outside equal, that is plus 10. Then simplify the values here. That is 1 by 3 is nothing but 0.33 V1 plus simplify the value here, that is 1.53 V2 equal to 10. This is taken as equation 2. Then simplify equation 1 and equation 2. Then you will get the node voltages V1 equal to 19.85 volts and similarly V2 equal to 10.9 volts. Okay, they are the calculation of nodal voltages by applying KCL at each node. Okay, suppose in the given problem, for example, we have to find out the current passing through 3 ohms. Then how to find out current passing through element I equal to V by R. What is the V value here? V1 minus V2 or V2 minus V1 across 3 ohms. That is this here across 3 ohms. Suppose in the problem find current passing through 3 ohms. Then you find out the voltage here V1 minus V2 or V3 minus V1. Here in this problem, V1 value is larger than, that's why you can take as the voltage across 3 ohms is nothing but V1 minus V2 by 3 ohm. That is I equal to V by R. Then you have to find out 19.85 minus 10.9 by 3. Yeah, we have to find out that value of the current here, nothing but here approximately you will get 3.1 amperes here. Okay, in this way you have to find out the current passing through element also. Okay, by applying nodal analysis. Okay, this is example for the consider the circuit having DC voltage sources. Suppose if the circuit consists of supernode. What is in a supernode? That is a voltage source will be joining between two nodes. Okay, that node is called the supernode. You have to solve the problem that is called the supernode analysis. Okay, for example, by taking this problem here, then this is the voltage source and also it is a dependent source value. Okay, voltage source, current dependent. Where is the current here? This is the current I value. Okay, after finding I value, then you have to find out this voltage source. That's why this is called the current dependent voltage source. Okay, and also this voltage source will be joining between this node and this node. That's why this is called the super node. At a time, you have to write down the super node equations by combining this node equation and this node equation. So that is called the super node equation of the given problem. Okay. For example, here find out nodal voltages by applying nodal analysis here. Okay. Then first consider node points. Okay. Consider this node point. This is the at this node point current will also be divided. Then taken as V1 node. At this point also current will be divides, then taken as V2 node. At this node point, current also divides, then taken as V3 node. Then simply applying KCL at node V1, at node V2, at node V3, then simplify the equations, then find out the nodal voltages. Remember, it is a super node. That's why at a time you have to write down the nodal equations by combining node 2 and node 3 equations. Okay, then I'm showing you how to write the equations. Okay. For example, what is the first step? Apply KCL at node V1. Then draw the equivalent circuit at node V1 here. Okay. At node V1, what are the elements are joined? That is 5 amperes is joined. Then and also V2 node here and 3 ohms are joined. What is the other element? That is the other element 5 ohms. 5 ohms will be joined here and this voltage will be V3. Then this is the V1 node value. This is V1 node. Then apply KCL at node V1. What are the assumptions here? All currents are leaving from that node here. Then apply KCL. Sum of entering currents. Entering current is 5 equal to sum of leaving currents. Then the current passing through 3 ohms is V1 minus V2 by 3 plus another current V1 minus V3 by 5. Okay, these are the equations. Then simplify the equation here. 1 by 3 plus 1 by 5 into V1 minus 1 by 3 V2 minus 1 by 5 V3 equal to 5. Then simplify the equation. You will get here 8V1 minus 5V2 minus 3V3 equal to 75. This is taken as equation 1. In the same manner, you can apply KCL at node V2. Apply KCL at node V2. Then draw the circuit at node V2. What are the elements are connected? 3 ohms connected, 3 ohms connected, 1 ohm connected, and voltage source connected here. That's why don't write that is apply KCL at node V2. That means apply KCL at node V2 as well as V3. That means we have to write down super node equation. You have to write down super node equation. Simply write down here. Understand clearly at this point. What are the elements are connected for V2 node point here? For V2 node, 3 ohms are connected. That means V2 minus V1 by 3. Similarly, 1 ohm is connected. Then what is the current passing through 1? V2 by V1. Okay. Plus at node V3. Again adding node 3 equations also. For node 3, what are the elements are connected? 5 ohms. That is V3 minus V1 by 5 and plus V3 by 2 equal to 0. This equation is called the super node equation. By combining at a time two node equations, that is called super node. Then simplify the equation, you will get here minus 16 V1 plus 40 V2 plus 21 V3 equal to 0. This is taken as equation 2. Then what about third equation? Then simply write down the third equation is the source. Where is the super node voltage source? Okay, that is the super node voltage source will be joined between two nodes. That is V2 and that is V3. Okay, this is the given problem is dependent source value here minus plus the value given 2 into I. Okay, then here plus symbol given to the V3 side. Then V3 is the larger value. That is V3 current passing from V3 to V2. Then V3 minus V2 equal to 2 into I. Okay. Clearly observe where is the current value given in the circuit. Okay, this is the position. I current is passing through 1 ohm. For 1 ohm, what is the voltage value? V2. Then I equal to V by R. Then R value is 1. Then from the circuit, then I value is nothing but simply V2 by 1. That is I value equal to V2 by 1. That is nothing but V2. Therefore, V3 minus V2 equal to 2 into V2. This equation simplify the 2 plus 1 that is 3. 2 plus 1 that is 3 value here. We will get 3 V2 minus V3 equal to 3. This is taken as equation 3. Okay, after writing nodal equation, you can simplify that equations. Then you will get the value of V1 is 12.87 volts and V2 is 2 volts and V3 is 6 volts here. V1 is 12.87. Okay, for example, in this problem also, find out the current passing through 5 ohms. Then what is the voltage for 5? V1, V3. We have two node voltages. According to calculations, what is the V1 value? 12.87 and V3 is 6 volts. That's why we can find out. For example, find the current passing through 5 ohms. Then how to find? That is, you can take as, for example, I5, current passing through 5 ohms. What is the voltage for 5? That is V1 minus V3. That is V1 value is larger than V3, then taken as V1 minus V3 by R value. R value is 5. Then simply find out the value is 12.87 minus 6 by 5. 12.87 minus 6 by 5. Then that value is 1.347. 1.347 amperes. Okay, like that you can find out the current passing through any branch after finding each node voltages. By applying KCL at each node, then simplify the equation, you will get the node voltages. You can find out at each node, you can find out the node voltages, then again find out the current passing through each branch by applying the nodal analysis. Remember, the important problem is super node problem. In university exams also, the problem, most of the problem is given super node as well as super mesh also. What is super mesh? Current source belong to the two loops. What is the super node? Voltage source belong between the two nodes. Then you can simplify the equations, you will get the required response. Okay. Subscribe our channel and share to your friends.